All right, of course, I got another phone call. So we were dividing into sevenths. How many should I shade? I would ask the kids. 4 for what? Yes, for whole models. So we'll lightly shade in 4 whole models. And then, yes, 1 out of 7 of the last one. So we all do that. And then I would get the kids to come back. All right, I want y'all to tell me what fraction was shaded out of this one. And if they say 1, say no, that's not a fraction, that's a whole number. If I want a numerator and a denominator to represent this model, yes, 7 sevenths, 7 shaded out of 7. Yes, 7 sevenths, 7 sevenths, 7 sevenths, 1 seventh. So if we compose, that's 7 plus 7 plus 7 plus 7 plus 1. 4 sevens is 28 plus 1. 29 what? Sevenths. Agreed. Denominator stays the same. And this is improper. It is incorrect. When the numerator is too big, when it's bigger than the denominator, we know this is a fraction that represents more than 1. And more than 1 what? More than 1 whole amount. A whole amount is 7 sevenths. So anything over 7 is more than 1 whole. Improper fractions are more than 1 whole amount. They're too heavy on top because they're holding whole models. All right, so that's one way we can change a mixed number to improper. We also can decompose. Decompose means deconstruct. So we can take away. Where composing is building part by part by part, decomposing is breaking it down. So 6. I want to think of like 6 whole amounts. 1, 2, 3, 4, 5, 6. 6. And if I want them to be whole amounts, which amounts up here are whole fractional amounts? Yeah, 5 fifths or 7 sevenths. So if we're divided into eighths, how many eighths do we need to be a whole amount? 8 is right. 8 out of 8, a whole amount. 8 eighths. 8 eighths. How many times are we going to do this? 6, that's right. 6 groups of eighths. All right, well, you took your 6 groups of eighths. What would be left? 2. 2 out of what? 8. All right, well, we're wanting to go from the proper mixed number to improper. Well, what do we know about the denominator? It doesn't change, still in eighths. If it's improper, what do we know the numerator is going to be? More than 8. It's going to be bigger. So 1, 2, 3, 4, 5, 6. 6 times 8 is 48 plus 2, 50. There you go. So instead of drawing models, which takes a lot of perfection and time, I can basically do the same thing but without a picture, if I know whole amounts. So on this next one, how many whole amounts do I need? 1. Okay, good. And who can give me the whole fraction for this, the whole fractional amount? How did you know it was 2 halves? Oh, very good, because the denominator is 2. If you're divided into 2, then 2 out of 2 is a whole amount. What's left? A half, which together makes 3 halves. If your numerator's bigger, you're improper. You're improper because you're the wrong way to write something more than 1. This is the correct way. This is the improper way. All right, the last way, everyone's favorite way, is backward C. Which this makes a lot more sense if I work backwards. If y'all look, 5 means 5 groups of 3s. Kind of like this was 6 groups of 8s, or 1 group of 2s, or 4 groups of 7s, or 2 groups of 5s. Well, I need 5 groups of 3s, which is 15. You have 1 extra, 16 thirds. Bam. All right, so what do we have groups of over here? We have groups of 10. How many? 5, yeah. So working backwards, 5 groups of 10 is 50 plus 7, 57 what? Tenths. You went from proper to improper. All right? Backwards C, what do we do first? Yeah, 1 times 4 is 4, plus 1, which is 5 what? 5/4. All these are ways to change proper mixed numbers to improper. All right, now let's talk about what it means to be improper. We kind of have improper, meaning not proper, like leaning back in your chair is the improper way to sit. Impropers have larger blank than blank. Well, we have larger numerators. Num, N-U-M, a, ters. Have a larger numerator than D-E, nom, I, nay, ter. And this type of fraction means you have more than one whole amount. Because if you were paying attention, a whole amount is a numerator and denominator. That's the same. If you're in fifths, 5/5 is a whole amount. Anything over that is not only improper, it means you have more than one. All right. Just like up here, where there are multiple ways to change mixed numbers to improper, to go from correct way to incorrect, same thing. There are lots of ways to go from improper to proper. All right, so draw a model. Same thing. Well, let's draw a circle. What are we, let's see, John, what are we going to divide our circle into? Fourths, very good. Denominator says D divided into fourths. All right, if I color in all fourths, how many do we have? 4 out of how many? 4/4. Is that 9/4? So what do we do? Yep, you draw another. Want it to be congruent, same size, same shape. If we color, how many should we color, y'all think? All 4? Now what do we have? 8, you're right, because 4/4 plus another 4 out of 4 is 8/4. We want 9/4. Okay, so another congruent circle cut into fourths. How many shaded? Yes, because 4/4 plus 4/4 plus 1/4 equals 8 9/4. That's good. But I want the proper, the mixed number. And remember, if I want a mixed number, I need a whole amount and a part. How many of these circles are whole? 2. What's left? 1 out of 4. Because that's 1 plus 1. So 2 and 1/4. And you could check yourself. 2 groups of 4 is 8 plus 1 is 9. Yep. All right. Priscilla, what should I divide my circle into? Halves. Very good. If you cut yourself in 2, hi-ya. How many should I color? 2. Okay, what fractional amount is this? 2 halves. Is that enough? No, what do we need to do? Draw another, right, congruent. How many should I color in? 1/2, good. Because 2 plus 1 is 3 halves. I want to change it from improper to proper. A mixed number has a whole and a part. What's your whole amount? 1. And what's left? 1/2. Perfect. So this is what you're working on tomorrow, is showing them the different ways. All right? We can also decompose. Decompose like you can deconstruct it into smaller, look right here, whole fractions. What would be a whole fraction out of 29/7? If I said to pull a whole fraction out. I'm sorry, I know y'all can hear my kids having a fit in the background. I apologize. Owen is being something else. A whole fractional amount would be 7/7. I heard him saying, "Don't push me." Who was pushing him? Nuh-uh. Ask Owen, Kevin. I swear, this is why I can't do anything now. 7, 7, 7, 7. What are 4 groups of 7s? 28. We need 29. So how many more do we need? 1 out of 7. So we want to go from improper meaning the numerator's too big, it's the incorrect way, and we want to go to a mixed number where you're mixing a whole and a part. How many of these fractions are whole amounts? 4 is right. 1, 7 out of 7, 4, and 1/7. All right, if I want you to pull a whole amount out, what would be a whole amount out of 77 tenths? 10 tenths, good. Using your D divided into tenths. So let's count by tens and let's write some of these whole fractions. So that'd be 10 tenths, 20, 30, 40 tenths, 50 tenths, 60 tenths, 70 tenths. How many more do we need? 7. And altogether, that makes 77 tenths, which I have. I need to look at it as whole amounts. 10 out of 10 is a whole amount. So that's 2, 3, 4, 5, 6, 7, and 7 tenths. 7 whole amounts and 7 tenths. And you can always go backwards and check. 70 plus 7, 77. The last thing we could do is use division. 58 is really 50 divided by 8. Think about it as the cowboy rides the horse. The cowboy rides the horse. And cowboys belong inside the barn, horses go outside. Or the cowboy belongs in the house, the horse belongs outside. Daddy is asking how many groups of 8 can be made out of 50, but Mommy's really saying what times 8 is closest, which is 6. Because 6 times 8, you write the answer, then you write that fact. This allows you to subtract. 10 minus 8 is 2. After sister, brother, is there anyone to bring down? No, so 6 remainder 2. All right, that's enough. Everyone's done. I'm sorry, y'all. You would think that I don't have to do this while I'm trying to video. 6 is your whole amount. 2 is your numerator. They're all done. I can't even video. Please go deal with that. Denominator stays the same. So 50 divided by 8, 58 is 6 and 2/8. And you can check by thinking backwards. 48, 49, 50. He needs to go too. They're just... All right, how do we say this? Not 3 2s. If you're cut into 2, 3 halves. This is a division line. It means 3 divided by 2. The cowboy's riding the horse. So you put the cowboy in the house and the horse belongs outside. 2 goes into 3 one time. Write the answer, then the fact. This allows you to subtract. After sister, there's no brother to bring down, so that's our remainder 1. This is your whole quotient. That's your whole answer. Leftovers are the numerators. Your D dividing number, denominator, stays the same. Right here, 12 fifths. 12 divided by 5. Daddy wants to know how many groups of 5 can be created out of 12. That one's a pretty easy one too. And that's right, because you write the answer, then this fact. No, this allows you to subtract. I'm sorry that my son interrupted me after my video has been interrupted 300 times. No. Is there any brother to bring down? No. So 2 remainder 2. So there's your numerator, the leftover. D denominator stays the same. And your whole quotient, bye Hondo, stays the same. 2 and 2/5. Make sure it's all clear for him. He brought some stuff over, I thought. Sorry, we had a kid over and our kids can't act right. All right, we're going to write fractions by each segment below. And we want the improper fraction. If it's improper, is this the right or wrong way? Improper is the incorrect way. If it's improper, what do we know? Yeah, the numerator's bigger than the denominator. And I also know it means more than 1. So what fraction does this bar represent? Yep, 5/5. And another 5/5, and another 5/5, and then 3/5. So that's 5, 10, 15 plus 3. So we've got 18/5 right here. Now then I want the mixed number. If you're mixing, what are we mixing? Right, whole and part. How many whole bars are there? 1, 2, 3. And then 3/5. He's outside. Use the backward C to check. 3 groups of 5 is what? 15 plus 3 is 18/5. So that's what I want them doing here. All right, same thing. 2, 4, 6, 8, 10. 10 tenths. 10 tenths. 1/10. 21 tenths. Why is that improper? Yes, because the numerator is bigger than the denominator. All right, if I want a mixture, I'm mixing a whole and a part. How many of those circle are whole circles? 2, and then what? 1/10. If I use the backward C, 2 groups of 10 is 20 plus an extra 1, 21 tenths. All right, read me this one about Margarita, girls. So Margarita puts point M on the line. All right, girls, read the question. All right, so we're looking for the distance point M is. Well, the first thing I would be doing is looking for whole numbers. What do we see? We see 2, 3, and 7. So what do y'all think we should do? Find the other whole numbers? How? Well, some kids might tell you that they notice the bigger hash marks are the whole numbers, and they'd be correct. So you could fill those in. Well, M comes after which one? Yeah. If you were measuring my pencil, and this is what I always showed the kids, M is 5 plus extra. So it's not 6, it's not 4, it's 5 and extra. So it's got to be J. What if we didn't have hash marks that were bigger? What would we have needed to do if we didn't have that other stuff? Well, you would have needed to find a whole amount. Could y'all tell me where a whole amount is? I would ask the kids. Hopefully they would know from 2 to 3. Well, you can look at that as a rectangle. And it's broken into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 spots, 10 parts. Because that's not whole numbers. That's not 2 plus 10 plus 10. It's 2 plus a part plus a part. All right, so they're tenths. So every 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a new set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. New set. 1, 2, 3, 4, 5, 6, 7, 8, 9. M is 9 out of 10. 5 and 9 tenths. All right. right here. We want to compose. We want to put these together. Well, think about an apple. If you cut it in half, what do you know 2 halves make? 2 halves equal 1, right? So I would look at this as 1 plus 1. Yeah, plus 1. So we have 3 and a half. So which of our models down there show us what we want? B. 3 wholes and a half. All right, down here. Y'all scan the question. What are we looking for? We want point T to be 4 3/4. Well, if it's in word form, I want to see it in standard form, where the digit stands. 4 3/4. So we want T to come 4 and extra, 4 and extra, 4 and, all right. So where's the whole set on this number line? It's not the, I don't want the whole, this might be all of the pictures, but where's one whole amount? Yeah, 3 to 4, or 4 to 5, or 5 to 6. Here's a whole amount. D, I'm divided into 1, 2, 3, 4. D, I'm divided into 4. And T is on 1, 2, 3 of the 4. So this is 4 3/4. That's your answer right there. All right, read about Quentin to yourself. All right, we're looking for the distance point Q is. Again, where is a whole set on this number line? Yeah, 0 to 1, or 1 to 2, or 2 to 3. Well, I would look right here, because Q, if I were measuring, Q is 1 plus extra. So it's not a piece. It's, well, so this is D. I'm divided into 1, 2, 3, 4, 5, 6, 7, 8. And Q is on 1 of 8. But not 1/8. This is 1/8. This is 1 out of 8. This is 1 and 1/8. Well, I don't see 1 and 1/8. What kind of number is 1 and 1/8? Yeah, it's a mixed number. How can I change a mixed number? How can I go from the correct way to the wrong way? Backwards C, okay. 8 times 1 is 8, plus 1 is 9/8. There you go. That's because it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/8, or 8/8 plus 1/8 equals 9/8. And then y'all can go through multiplication practice.